Hi, in this Lightboard session we're going to talk about CloudHub scaling. Now there are two types of scaling available. You can scale horizontally and you can scale vertically. Now vertical scaling, nice and easy to understand, throwing more CPU and memory at the problem. Now in CloudHub, when you scale vertically, you're allocating more CPU. So this means that you get attached with it a certain amount of memory. So as far as your sizing, you can start at the 0.1 vCore size and you can go on up, okay, in increments. So there's quite small ones, 0.1, 0.2, then you jump to 1, 2, and so on up. Now as far as memory, each of these different allocations will have a certain amount of RAM attached to them. Now, if you're a CPU intensive task, then CPU is going to be the reason you're scaling, but you could be memory intensive. That means you need to scale the CPU to get more memory. So in CloudHub, because it's running on EC2 infrastructure, it needs to be scaled together. So scaling the CPU scales the memory, and if you're memory bound, then you're going to have to scale the CPU to get more memory. Okay, so vertical scaling would be the ideal because the minute you start to go horizontally, so if you're scaling from one worker, so scaling this way, nice and easy. Throwing more CPU, very minimal impact to any sort of code that you have. You just got more grunt and more memory available to do it. But the minute you start to go out, so you add extra workers, you start to have to think about things like, what about state? Is there some shared state that I need to consider with this? Because if we were, say, for instance, using our worker to detect duplicate requests coming in, then if I'm trying to work out whether I've processed something before, having it local to the worker is not going to work. So we look at our options for state, and you've got things like object store, and you've got VM queues. And those, if they're local, if they're in memory, then if we want to distribute load to other workers, we're going to have to go into some sort of shared queue. If we want the key value pairs that we're putting in object store to be shared amongst all the workers, it needs to be externalized. So that would be flicking over in your code to use the persistent options, because that then means that we are using the object store v2 service and the persistent queues. Okay, so scaling horizontally would also mean that inbound requests need to be funneled to all of those different workers. And that's why we have load balancers involved. Okay, so your load balancer's job is to provide a united front so that requests can come in and then get distributed. It has some other benefits, as we've talked about, for things like zero downtime deployment. But the minute you scale horizontally, load balancer becomes an essential thing, unless the client can balance requests between the different endpoints. But that, in a nutshell, is some of the types of scaling available. Now, in some cases, scaling horizontally is done for availability, because you don't want a single point of failure. Other reasons would just be around performance, so you're juggling the vertical scaling options versus horizontal. In extreme cases, using state management that's shared might be the bottleneck, okay? Because if you scale out and you're using this shared state, then that might be an unacceptable performance characteristic for your application. So you may choose to sacrifice availability or horizontal scaling in order to get extreme cases of lots and lots of CPU, but using in-memory object store or in-memory VM queues for performance reasons. So scaling the extremes of vertical might be a requirement for that situation. So that sums up the horizontal and vertical scaling options. You get to pick those based on the requirements, whether you need availability, whether you need raw performance, but just be mindful, any horizontal scaling, you've got to consider state.